Welcome to the next session of square and square roots. Dear students, what we have already discussed in the previous lecture is column method, diagonal method, square of the numbers ending in 5 and some of the questions from exercise number 3.1. And now in this topic, what we people are supposed to discuss is first is remaining questions of exercise 3.1. Then we will discuss square roots. Then we will discuss methods of finding square roots by successive subtraction of odd numbers. Then we are having tens and ones method. After that we are having finding square root by prime factorization. Now we will continue with exercise number 3.1, what we have already, some of the questions what we have already done in the previous lecture. Now our first question is like this. Find the square of the following numbers using the column method. Now our first part from that is 24. So as already discussed there, in the given number which is 24, we will take A as 2 and B as 4. What we have already discussed earlier is that in such type of questions, what we people are supposed to do is we are supposed to take 3 columns. Let the columns be column number first, column number second and column number third. As I have told you in the previous lecture that you can relate it with A plus B ka whole square, that is A square plus 2AB plus B square. Now again here, if you will go through with this part of the question, you can see here in column first it is A square, then we are having 2AB, then we are having B square. Now dear, what you people are supposed to do, you can have it A square, that is 2 square. Now it is 2AB is 2 into 4. Now in column number third it is 4 square, that is your 16. In column number second it is 2 into 4, which is 16, that is 4 2 are 8, 8 2 are 16. Now in column number first it is 2 square, that is 2 2 are 4. Now you can see from the column number third, I have underlined here number unit digit of this number, that is 6, and the remaining digit is 1, which is to be added to the column number first here, that is 16. That is 16 plus 1 is 17. Now from this 17, what I am supposed to do is, we people are supposed to underline 7, that is the unit digit of this column number second, and the remaining tens digit number is to be carried over there and to be added with the column number first, where we are having 4 plus 1, that is 5. Then we can see here 5 is also underlined, that thus we can say that 24 square is, now we are taking the underlined numbers, from the column first it is 5, and from the column second it is 7, and from the column third it is 6. Now we are arriving with the answer, that is 24 square is 576. My dear students, the remaining part you can do yourself, same parts. Now in question number 10, what you people are supposed to do is, you are supposed to say find the square of the following numbers using diagonal method. Your part number first from that question is 41. As already discussed in the previous lecture, that is, if you people are supposed to have 2 digits, then you can say it can be done with 2 into 2 grids of squares. If we are having 3 numbers, 3 digits you can say, then it is 3 into 3. If we are having 4 numbers, then it is 4 into 4. Now in this very part, you people are supposed to draw 2 into 2 grid of squares, as you can see it over here, and draw the diagonals of a subsquare. Now we are having 4 subsquares here. We should draw diagonals to these subsquares. Now write the digits of the number to the square along the left vertical side to the subsquares, that is vertical, and at the top horizontal side. Now you can see here it is 4 1 from the left side, and upwards it is also 4 1 there. Now what you people are supposed to do, you are supposed to multiply, that is 4 from the vertical side and horizontal side, top one and the left side, that is 4 4s are 16. Now its unit digit is to be written below that diagonal and its tens digit is to be written above the diagonal, as we have already discussed it. That is 1 6. Now it is 4 1 are 4, that is 0 4. Unit digit is 4 and tens digit we don't have any number that you can say it is 0. Now it is 1 4 are 4, that is 0 4. Again it is another, that is 1 into 1. You can see it over here, that is 1 into 1 is 1. So it will be 0 1. Now what you people are supposed to see from this diagram is we are taking the arrow which indicates that I am taking it diagonally, that is 1 with the arrow, and to another, when we move to the another step of this question, that is I am supposed to add, that is 4 plus 0 plus 4 is equivalent to 8. Nothing is carried there, so we can move to another step, that is the diagonal one, that is 0 6 0, that is 0 6 0. Nothing is carried out, you can take 6 as it is. Now another is 1, that is we are having only one number there, so we can say 41 square is, you can see over here that it is the numbers which are indicated by this arrow is 1681. So our answer to this question is 41 square is 1681. The another question, that is question number 11. Your question number 11 is like this: find the squares of the following numbers ending with 5. As you people know that in such type of questions, what we people are supposed to do is, if we are having a question like this, it is a is equivalent to 25. What you people are supposed to do, deleting 5 from the number that is 25. The number which is 25 and we are supposed to delete its ones digit, that is 5. The new number we obtain, a new number, that is 2. We multiply 2 by its successor, that means the successor of 2 is 3. After that what we get, as I'm telling you, we are supposed to multiply it by its successor, that is 2 into 3, that is 6. Suffixing 25 to the product, we get 625. Thus 25 square is 625. Moving to another question, that is your question number 12. Observe the pattern in and fill in the blanks. You can see in this figure that it is 4 3 5, then in row. Now it is 6 8 10 in this row. It is 8, then we are left out with a number which is not there. What we people are supposed to find is this number. Then we are having 17 here. Dear students, here we may observe that the numbers follow a common pattern in each row. That is, if you can see over here, if we are squaring a number, that is 6 square plus 8 square, it will be 36 plus 64, that is 100. Now from this you can have it that in this row which is 10, that is 10 square. We can take it like this: let the missing number be x. Therefore by the same pattern we can write 8 square plus x square, which is the missing one, is equivalent to 17 square. So you can do it like this: it is x square is equivalent to 17 square minus 8 square. We are transposing it. So 17 square is 289 minus 64, that is 8 square. So we will get 225. So 15 square, x is equivalent to 15. Are you getting me or not? Okay. My dear, after that, we are supposed to say what square roots of the numbers are. As you people know that what's written here also, that 25, 36, 49, etc. are perfect squares. My dear students, first of all, do you know what are perfect squares? I will remind you people that a perfect square is a natural number which can be expressed as a product of pair of equal factors is known as a perfect square. So we can also know that from this, if we will take an example like this, it is 25, that is 5 square, it is 5 into 5. 36 is equivalent to 6 square, which is 6 into 6. 49 is equivalent to 7 square, which is 7 into 7. My dear, you can see that 5 is called the square root of 25 and 6 is called the square root of 36 and 7 is called the square root of 49. Thus, you can say square root of a number, if we are taking a number, say m, is that number which when multiplied by itself, when you multiply a number by itself, gives m as a product. So, if n is the square root of m, then m is called the square of the n. So, if you can take an example like, if I am putting for m is equivalent to n into n, I am putting m as 25. That means its m will be 5 into 5. You can denote it by the square root of m is denoted by under root of m. You can see it over here. The symbol which you people can see means square root of a number. Now, dear students, another method from this square root of numbers is finding a square root through repeated subtraction. Now, this method can be used for small perfect square numbers. Say, we can say up to 300. Beyond this, my dear, it becomes time consuming. If it can be done, but it's time consuming. If you are taking numbers beyond that, you can do them, but while doing the question, it will be time consuming. Let's recall that the sum of the first n odd natural numbers is n square, what you have already done. So every square number can be expressed as a sum of the successive odd natural numbers starting from 1. If I am giving you an example from this question, that is, if I am taking a number 9, you can see by this method that if 9 is 3 square, it's a perfect square, then 9 can be expressed as 1 plus 3 plus 5. In the same manner, you can say it from the example that if we are taking it vice versa of the number, that is, from this example, considering the number 25 by successfully subtracting a number, that is 1, 3, 5, 7 and 9 from it, we can have it like this. It is 25 minus 1 is equivalent to 24. Then successive number, which is an odd number, that is 24 minus 3, that will be 21. And another step for this is the remaining number which is left over here is 21. Now we will move to the third step, that means 21 minus 5 is equivalent to 16. Now moving to the fourth step, it is 16 minus 7, that is 9. Moving to the fifth step, that is 9 minus 9, that is 0. This means 25 is equivalent to 1 plus 3 plus 5 plus 7 plus 9. Also, 25 is a perfect square. Now we can see it from here. From 25, we have subtracted successive odd numbers. The successive odd numbers, we start from 1 and obtain 0 at the fifth step. You remember this thing, while whenever we are obtained 0 and we are doing the repeating subtraction to the numbers, while arriving the 0, we are saying the answer for that question is where we get 0 to the number. Here in this example, you are seeing here that we are getting it in the fifth step. That is, we can say therefore under root of 25 is equivalent to 5. Finding, now another method is finding square root through tens and ones method. My dear students, the square root of the perfect square up to 4 digits can be easily found by finding their ones and tens digit. For using this method, we have to follow the steps. As you will be knowing by the properties of the square numbers, it's very important for you people to remember the properties. Okay? Now, if you observe that the ones digit of a perfect square and determine the ones digit of the square root as discussed earlier. If we are having what you have already read and what is known to you people is, if the perfect square has 1, 4, 6 or 9 as its ones digit, then there are two possible ones digit. For example, for 1, possible digits are 1 and 9, what you have already done in the properties, or what you have already known to you people. For 4, possible digits are 2 or 8. For 6, possible digits are 4 or 6. And for 9, possible digits are 3 or 7, sorry. If a perfect square has 0 or 5 as its ones digit, then its ones digit of the square root will also be 0 or 5 respectively. Now moving to the second step of the question, which is, now if you are taking any number, say 4 digits, 6 digits, 5 digits, you can have it like this. Strike out from the right the last 2 digits of a number. If nothing is left, stop. The digit obtained in the step first is the answer. My dear students, I can explain to you people step number second like this. If, for instance, you are taking an example of 64. 64 is a perfect square. You can see the ones digit of this 64 is 4. Then you can say, then there are two possible ones digits. That is 2 or 8. 2 or 8. You are having only two possible digits from this 64. That is 2 or 8. Now we will arrive with the answer that either its answer is 2 or 8. In this step, if you are taking an example like 64, now either the answer is 2 square, either the answer is 8 square. That is, either your answer is, you can do it by multiplication simply. That is 2 into 2, that is 4. Or 8 into 8, that is 64. Now your answer from the question is 64. That is 8 square is 64. Now coming to the third step, now consider the leftover number. If, for example, consider the leftover numbers means if you are having 4-digit numbers, okay, if you are having 5-digit numbers, it can be with this. Now determine the largest ones digit number whose square is less than or equal to the leftover number. This is the tens digit of the square root. If there are, note for you people is, which I was just discussing to you people, if there are two possible answers, then the correct answer can be found by the actual multiplication. If we are taking an example like find the square root of 3969 by finding its ones and tens digit. So we can have it like, solution for the question may be, ones digit of the given number is 9. What is known to you people is, so the possible ones digit of a square root is either 3 or 7. Now let us strike out 2 digits from the right. The 2 digits from the right is 69. We are striking it out. Now we get the number 39. You can see over here if the number is 3969. So I am striking 2 numbers to the right of the number, that is 69. So the left out number is 39. Now what we people are supposed to do is, we are supposed to take a number, so square of a number which is less than to this 39. We are taking a number, in fact we are taking 2 numbers, the one which is the least one and one which is the greater one. That if we are taking a number, say 6, that is 6 square is equal to 36. The square of 36 is less than 39. Whereas if we are taking 7 square a number, that is 7, we are squaring a number 7, that is 7 square is equal to 49. So 49 is greater than 39. Hence the digit of the square root is 6. So we can say it like this. So the square root of 3969 is either 63 or 67. But as you can see by the multiplication, that 67 square is 4489, which is not equal to 3969. Then obviously we will arrive at the answer, which is 63 into 63. That means under root of 3969 is equal to 63. Square, another method is find square root through prime factorization. Okay, now it's when a given number is a perfect square, we find the square root through prime factorization method using the following steps. There you people are supposed to follow these steps and listen them carefully. First of all, what you people are supposed to do is find all the prime factors of the given number, group the similar factors into pairs, select one prime factor from each group and multiply them. Their product is the square root of the given number. As you can see here from the example, that is, find the square root of 7744. While doing it, and from this picture it's clear that by prime factorization we get 7744. Now we are arriving with this. It is 2 into 2 into 2 into 2 into 11 into 11. Now we are making pairs of the prime numbers. That is 2 into 2, first pair 2 into 2, second pair 2 into 2, third pair 11 into 11, fourth pair. Now how can I arrive at the answer? From these pairs we are supposed to take only one pair. You can see here that from these 2 pairs I am taking 1, 2. From that pair I am taking another 2. From that pair I am taking another 2. And from that pair 11 I am taking only 1 11. So we are arriving with the answer, that is 2 into 2 into 2 into 11. That is root of 7744 is 88. Thank you dear. Hope you enjoyed the session. Stay home, stay blessed.